Morning. Uh, Students, am I audible to you? Swati?
Yes, sir.
Okay, just wait 2 minutes for rest of the students. Okay, then we will start the session. Okay, so now I think the screen is visible for all of you. It is visible.
Yes, sir.
Okay, so actually, uh, we have in the last class we have started the discussing about the syllabus part and the COPO mapped. Okay, so in that class we saw the syllabus and all the things and the so what is a course outcome and what is program outcome we have discussed in that class. Okay, so today this is the actual our first class. This is the brief. We will discuss the brief introduction about the optical fiber communication. Okay, so before going to discuss the optical fiber communication, first here I make a slide here. So please go through this slide. That first we will discuss the optical fiber communication. Then we will discuss the history of optical fiber communication. Then this is the introduction part. So in that case, this is the major milestone in electrical communication. Okay. Next is the major milestone is electrical communication. This is the evolution of a fiber optic system. Okay, in that slide, I will discuss you the first, second, third, and fourth and fifth generation. Okay, so these are the evolution part. Next is the element of an optical fiber transmission link, and uh, here this is the block diagram of OFC system. OFC system means optical fiber communication system, and the last one that is the uh, yeah, this is the transmission window and bandwidth. So these topics in this class we will cover. So first, mm, and before start the session, that is the optical communication. In your fourth and sixth semester, you already studied the analog communication as well as the digital communication. Okay, and I think in sixth semester, sixth semester, you have also studied the microwave. So you have a basic idea. I assume that you have a basic idea in communication system. So can you tell me what is the communication system? Swati, can you tell me what is communication system?
Sir, it is the exchange of information.
Yeah, it is the exchange of information. Yes. Yes, it is absolutely correct. You can say that there is a process of exchange of message with the help of electronic device. The message sent from transmitter end to receiver end. This system is called the communication system. Okay, and you have studied the analog and digital communication system. So you have an idea regarding the analog as well as the digital communication system. So here another person, that is Sushil Kumar. Sushil, can you tell me what is the difference between analog as well as the digital communication system? What is the difference between analog and digital communication system? So if we consider, okay, so I am saying, you just listen here. Okay, so in analog communication system, mainly the data is transferred with the help of analog signal in between the transmitter and receiver. Okay, and any type of data is transmitted or transferred in analog signal, and any data which is converted into electrical signal first, then after that it is passed through the communication channel. And normally the analog communication uses the continuous signal which varies in amplitude, phase, or some other the property with the time in portion to the of a variable. Okay, so this is the concept of or properties of analog communication system. So if we consider the digital communication system, in that case, in digital communication system, the digital signal is used rather than the analog signal for the communication in between the source or and destination. Source or destination means the transmitter and receiver. Okay, and the digital signal consists of discrete values rather than the continuous values. In analog communication, it takes the continuous value, and in digital communication, it takes the discrete values. And in digital communication, the physical transfer of data occurs in the form of digital bit, that is 0 or 1, over a point to point or point to multiple transmission medium. Okay, so in one thing, in digital communication, the digital transmission, the data can be broken into packets as the discrete message, and which is not allowed in the analog communication. So these are the main properties of analog as well as the digital communication system. So from these properties, you can easily understand what are the difference for the case of analog communication as well as for the digital communication. Okay, so first we got the analog communication, then we got the digital communication. Okay, and one thing you should know that before the Maxwell equation, it is difficult to understand it is difficult or established to understand the communication system. So after the Maxwell equation, the communication system is developed. And first we got the analog communication system, then we got the digital communication system. Now we are working with the optical fiber communication system. Okay. So if we compare with the analog communication system with digital communication system, so in that case, we see that the digital communication system is digital communication system is more compared to less complex rather than the analog communication system, as well as here the digital communication system, the time complexity is less. Okay, so we can say that it is much the digital communication system is much better than analog communication system. Now we are working the optical fiber communication system. So first, why we are working with optical fiber system, or what are the benefits we will get from the optical fiber system? Okay, so till now whatever I have said, it is clear for all of you? Swati?
Yes, sir.
Okay. So one thing, uh, uh, yes, later part we will discuss what are the benefits we will get from the optical fiber system. So before going to that, first one question, because you already studied the analog and as well as the digital communication system. So can you have any concept regarding the baseband communication system and bandpass communication system? What is the concept of baseband communication system and bandpass communication system? Anybody has any concept regarding the baseband and bandpass communication system? Okay, so the concept,
Sir,
yeah.
sir, baseband is very low frequency, nearly equal to zero, and
Sorry,
band
baseband.
pass. Sir, baseband communication in baseband communication, the frequencies are very low, nearly equal to zero.
And for the
The
case of
frequencies
bandpass,
are very low.
for the case
A
of
band
bandpass,
pass, sir, for band pass in band, sir, I don't have clear idea about that.
okay, okay. So whenever you studied the analog communication system, I think you studied the modulation. What is modulation? Okay, so modulation means suppose we have a signal that is called the massive signal or baseband signal. Normally the massive signal has the low frequency, and you have one thing term that is in communication system, that is the carrier signal. Am I right? Hello?
Yes, yes, sir.
Yeah. So whenever and for the case of baseband communication, normally when we transmit the massive signal from one end to another end, it is not possible with the help without help of carrier signal. Okay, so with the help of carrier signal, actually the carrier signal is a high frequency signal and massive signal is a low frequency signal. Okay, so in baseband or massive signal, there is no need of modulation. No need of modulation. So we can say in baseband communication, normally there is no carrier signal. only there is massive signal which is transmitted from one end to another end. Okay, and this is called the baseband communication. There is no carrier signal in baseband communication, but whenever the bandpass communication, there is a concept of modulation. So when we need the modulation, we need the carrier signal. Without carrier signal, the modulation cannot take place. So with the help of modulation, with the help of carrier signal, the massive signal can transmit from one end to another end for a long, and the distance is very long. Okay, so this is the main concept. In baseband communication, there is no carrier signal such way, and in bandpass communication, there is a carrier signal. Okay, so with the help of carrier signal, the modulation takes place in bandpass communication, and you just heard that in baseband communication there is no carrier signal, so there is no modulation takes place. So can you give me one example of baseband communication? You already studied in digital communication. What is the example of baseband communication?
Sir, satellite communication?
No. I think you have studied the PCM, pulse code modulation.
Yes, sir.
You studied PCM in digital communication. So PCM or pulse code modulation is an example of baseband communication. And for the case of bandpass communication, please give me two examples from digital and two examples from analog. Do you know the example of bandpass communication system?
No, sir.
Okay. So bandpass communication system is in digital. I think you studied the ASK, PSK, FSK, QPSK. Amplitude shifting, frequency shifting, phase shifting. These are the example.
Phase shifting.
Yeah, these are the example for bandpass communication system. This is for from the digital, and for analog, amplitude modulation, frequency modulation, and phase modulation. AM, FM, PM. You can say these are the example for bandpass communication from the analog. Okay, analog part. I think now is clear what is baseband and what is bandpass communication, and what are the example of baseband as well as the bandpass. Okay.
Yes, sir.
Okay. Now, for the case of communication system, there are lots of parameter. Okay, lots of parameter. With the help of lots of parameter, we can conclude that the system is efficient or inefficient. Okay, and system is efficient or inefficient, or more complex or less complex. So there are lots of parameter in communication system. So if we focus mainly 2 to 3 parameter for the case of optical fiber communication system, in that case, first we will focus on bandwidth. Next is bit rate, and the third one is the noise. So first we will focus in these 3 parameters. Okay, so in optical fiber communication system, we will see that we are getting much bandwidth. Here the bit rate is high, as well as the noise is less. We are getting less noise from the optical fiber communication system. Okay, so that's why it is highly efficient. And you can see nowadays the companies are providing the optical fiber. We are using now the Geo fiber, Airtel Extreme fiber. So these are the optical fiber communication system now we are using. Okay, so first the bandwidth. So in the if we consider the bandwidth optical fiber, we are getting the much bandwidth. If we getting the much bandwidth, then we can transmit the more number of signal in a stipulated bandwidth, as well as here the in optical fiber communication bit rate is high. Bit rate is high means uh, in a seconds we can transmit more number of data from transmitter end to receiver end. Okay, so if we compare with analog and digital communication, here we can see in a same time at the receiver end we are getting more number of data. Okay, more number of data. So one thing, the speed of the optical fiber communication is also high. So it is easily acceptable. The customer it is giving the customer satisfaction also. And one thing, the noise. Okay, whenever it is transmitted from transmitter to receiving end, in that time the mixing of noise with the data is very less. Okay, so the distortion of signal is compared to less compared to the previous two system, that is the analog communication as well as the digital communication. Okay, so these are the main three parameters this is the main three parameters, that is the bandwidth, bitrate and noise, which are giving the benefited to the customer. That's why the optical fiber communication is widely used at this moment. Okay, so still now whatever I have told, it is clear for all of you.
Yes, sir.
Now I am watching here the Sweta Kumar. Sweta, I think you just joined 1 or 2 minutes ago, but it is little bit difficult for you to understand at this moment. Okay, because already 20 to 25 minutes left. Already 20 to 25 minutes gone. Okay, so you just try to enter the class in the proper time. With the proper time, you just try to enter the class. Okay, okay, Sweta.
Yes.
Okay, so I hope from the next class you will maintain the time, class timing. Okay, so now we will discuss, that is the history of optical fiber communication. So here you can see the optical fiber suggested in 1966, and it is suggested by the Cow and Hockham. Okay, 1970 there is introduced the optical fiber, which is conical glass, and this fiber is 20 dB per kilometer and 1 micrometer. Okay, in 1970 there is a semiconductor laser with continuous wave operation at room temperature. In 1980 the use of optical fiber communication is widely spread, and it is used as a SMF and MFF. Okay, so SMF means single mode fiber and MFF means multi mode fiber. In single mode fiber we can transmit only one signal, and in multi mode fiber we can transmit multiple signal at a time. In the later part we will see the SMF as well as the MFF. In 1990 the used as a optical amplification for increase the repeater spacing and the WDM. WDM means wavelength division multiplexing. In the later part, we will discuss what is repeater spacing and what is the WDM, wavelength division multiplexing. Okay. Okay. So these are the major milestone in electrical communication system. Okay. Now the evolution of fiber optic system. The first generation of light wave system was used in gallium arsenide semiconductor. I think in semiconductor physics or basic electron, you already know what is the gallium arsenide. Okay. And one thing, for the case of optical fiber communication, in analog communication, there is a massive signal and there is a local oscillator. With the help of local oscillator, the carrier signal takes place and the modulation takes place, and after modulation the signal is transmitted from transmitter end to receiver end. One thing, okay, in digital communication, first the analog signal is converted to digital signal, then it is transmitted from transmitting end to receiver end. But in optical fiber communication, there is also a transmitter and receiver part, but in transmitter part, mainly the source is as a laser, okay, and light. So the light, the message signal in the forms of light, okay. So and the modulation is takes place with the help of laser. So after that modulation, this ray of light transmitted, and the receiver end, there is a one device, that is the photo detector. With the help of photo detector, we can mainly in the receiver part, with the help of photo detector, the transmitted signal detected, and we are getting the original massive signal in the receiving end. And this photo detector here, their pin diode or PN junction diode is used as a photo detector. Now the first generation here, for the first generation system, the gallium arsenide semiconductor laser is used, okay, and the operating region was near 0.8 micrometer. And this is the other specification for first wave, first generation. Here you can see the bit rate is 45 MB per second and the repeater spacing is 10 kilometer. So what is the repeater spacing? Can you have any idea? Can you tell what is repeater? Have you any concept about repeater? Shweta? So repeater means normally for the case of repeater, repeater normally, suppose you are thinking that you are traveling from Dumka to Kolkata, okay. So suppose you are traveling, so after suppose 10 kilometer you are traveling, so repeater means after certain distance there is a repeater. Normally this repeater recognize the uh, transmitted signal. If there is a problem, or if it is not synchronized properly, then this repeater gives a information to the receiving end as well as the transmitting end. So again from the receive, and this repeater give a signal to the transmitting end, and again the signal is regenerated. Okay, so the signal is regenerated, and at the receiving end we will get the proper output. This is the concept of receive repeater. Okay, next is the second generation. Here the second generation, you can see the bit rate is 100 MB per seconds to 1.7 GB per seconds. And here one thing, the repeater spacing is 50 kilometer. In the first generation it was 10 kilometer, and here it is 50 kilometer. In third generation, you can see the bit rate is compared to much higher compared to the second generation. Here it is 10 GB and repeater spacing is 100 GB. So we can watching here that whenever the generation is updated, we are also getting the high bit rate as well as the uh, less repeater. Less repeaters means in first generation we are using repeater. Here the repeater spacing was 10 kilometer. In second generation it is 50 kilometer. In third generation it is 100 kilometer. So whenever the generation or system is developed, uh, the range of repeater is high, so we are using the less number of repeater. So in fourth generation, the fourth generation uses the wavelength division multiplexing, and here the bit rate is 10 TB per second and repeater is greater than 10,000 kilometer. And in fifth generation, it is repeater is 24,000 kilometer to 35,000 kilometer, and the bit rate is 40 to 160 GB per second. Okay, so from the generation we can conclude that after fifth generation we are getting the much repeater spacing. So much repeater spacings means we are using the less repeater in our system. So less repeaters means it is the cost is compared to less, and one thing, the bitrate is very high. Bitrate is very high, so we will get the high speed data at the receiving end. Okay, so normally the element often, this is the optical fiber transmission link. In all communication system we will see that there is a transmitter, information channel, and the receiver. Okay, so this is the block diagram of optical fiber communication system. Okay, so here this part is for the transmitter and this part is for the receiver. Here you can see the message signal. This is the origin, and this message signal may be the text signal or the video signal. After that, this is the modulator part, and this is the carrier source. And here this is the in the channel there is a coupling, so this is a channel coupler. And after that, this is the information channel. In the channel there is a repeater. Okay, in the optical fiber there is a repeater. After that, in the receiver part, first this is the optical detector. So optical detector detect this transmitted signal first, then after that it is amplified by the amplifier, and after this is processed, and at final output we will get the message signal. So in the later part we will discuss the block diagram. The each of block we will discuss separately. Okay, one thing. Okay, so this is the transmission windows and bandwidth. In the later part we will discuss the attenuation and what is attenuation. Okay, so attenuation means the losses. So here you can see there is a curve between the attenuation, the unit is dB per km, and the wavelength is nanometer. So here you can see normally here the when the attenuation loss is high, here you can see the curve is gradually decreasing. Okay, but here it is increasing. So here in this point the attenuation loss is very high, but after that you can see the attenuation loss is decreasing. Here it is the lowest. But here again, the attenuation loss is high, and in this point it is highest. After that, again it is decreasing. So these 2 points, actually the attenuation loss is very low. In those 2 points, the attenuation loss is very low, and our aim is to get the minimal attenuation loss. Minimum attenuation loss is required for the optical fiber communication. If the attenuation loss is very high, so we can say that the system is not efficient or inefficient. Okay, so in from this figure you can see both 2 places the attenuation loss is very high compared to wavelength. Okay, so here in this case, this is called the O band and this is called the S/U band. Okay, so for today this is up to the class. Okay, if you have any query, we can discuss in the next class. So now I am ending this session. If you have any doubt, you can ask. Sushil. Hello.
Hello.
Sushil, are you getting my voice?
Yes, sir. Yes, sir.
But I saw that the whole class, your audio is not connected. Just 2 to 3 minutes ago, you just connected your audio.
Okay.
Why?
But sir, मैं connect किया था but
No, it was
earphone
in the whole class. Out of 40 minutes, I think 38 to 37 minutes, it is not connected from your side.
सर मेरे ये जो है ना जैक में इशू है कुछ, तो मैंने ईयरफोन लगाया था बट आपका आवाज नहीं आ रहा था क्योंकि आई थिंक सो मेरे को लगा कि वो कनेक्ट करने के लिए आपने वेट कर रहे हो, बट वो
मेरा
मैं अभी
आवाज आ
देखा
रहा
वो
है आपका, मेरा आवाज आपका पास तभी तो जाएगा जब आप कनेक्ट करेंगे. Without your connection, you will not get the audio from our end. I hope from the next class,
okay.
you will solve your problem.
So yeah sir, okay.
Okay, so thank you for your participation in the class. We will discuss next topic in the next class. Okay, thank you.
Sir, do you have 5 minutes time?
Do you?
Hello.
Sorry.
Do you have 5 minutes?
Yeah, tell me.
Can you please explain the graph, sir? Only graph. Yeah, SU band.
Okay, so actually the time is almost over. It is less than 1 minute. Okay, I am trying. This is the curve between the attenuation and the wavelength. Okay, so what is attenuation? Attenuation means the signal when the transmitted from transmitting end to receiving end, there is a some parameter which actually disturb the signal, and there is a loss. This is called the attenuation loss. Okay, so if the attenuation loss is very high, so at the receiving end we will get the distorted signal. Okay, so our aim is to get the minimal attenuation less signal. Okay, so here you can see the attenuation in this point, the attenuation is very high, and in this point the attenuation